Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about another technique in integration, which is called the integration by parts. So, first of all, recall that differentiation and integration are just inverse processes. So, therefore, if let's say you have two functions here, f and g, and both are differentiable functions, and according to the product rule, this formula you actually have seen that in the previous chapter, chapter 3. And according to the product rule, if you have these two functions together, they are multiplied together. And if you want to differentiate this function, it becomes fx g prime x plus gx f prime x. So you take turn in differentiating these two functions. And because of that, because the process are inverse processes, if I have this one and I integrate this one with respect to x, so this one, I integrate this function with respect to dx, what I will get is I will get this back. So the answer will be fx times gx. So now we are going to use this idea and we're going to consider this representation here. Well, I hope you can see that if you separate the terms here, you can evaluate them separately. So this one will be fx g prime x dx plus gx f prime x dx is equal to fx gx. Now, because of that, based on this, you can have this equation. Okay, because of that, you can see that therefore this guy here, you can have this guy here, which is this one. This is equal to having fx gx minus this guy. So that's what you have here, fx gx minus this guy over here, gx f prime x, the integral of gx f prime x with respect to x. Okay, and if you let u equals to fx, so if you let u to be equals to fx and v to be equals to gx, so therefore if u is equal to fx as a function with respect to x, therefore du dx is the same thing as finding the derivative of fx, so you get f prime x. So therefore du is equal to f prime x dx. So this is what you have over here. And the same thing, if you have v is equal to gx, this is a function of g. So if you integrate, if you differentiate v with respect to x, this is the same thing as, you get the first derivative of it. So dv is just g prime x dx. And this is what you have over here. And by the substitution rule, what you have here is by substitution rule, we use substitution. So therefore, this one can be represented as u, and this one g prime x dx, which is this one, can be represented by dv. So here you have u dv, and for this part here, this is u times v, so you have u times v. This one is v, so this is v, and this one is f prime x dx, okay, which is just equal to du. So you have this formula. So this is the formula that is related, that is to do with the idea of integration by parts. Okay, u dv, the integral of u dv is equal to uv minus v du. So that is how you remember the formula when it comes to integration by parts. So now maybe what we can do is we can try some of the examples, and to see how we can apply the formula given in the previous slide. Okay, so for the first one is x sine of x dx. Now what we need to do is we need to be able to see which one is u, which one is dv. So this is the integral given here. So we need to identify which one is u, which one is dv based on this integral. So the rule of thumb is you should always choose u that is when you differentiate this function, it gets simpler, it becomes simple. So obviously our choice is this one will be my u, because when I differentiate this I will get equal to 1, so it gets simple. Whereas if I choose this one as u, if I differentiate this, I will get cosine of x. It doesn't get any simple. Okay, so based on this, I'm going to choose this as my u and this as my dv. Okay, so that's what I'm going to do. I'm going to do that. And based on that, what I can do next is I can continue with the formula given here. The formula says, I'm going to erase this so that you can see the formula clearly. So the formula given here is, first of all, choose which one is u, which one is dv, and then you can apply this formula, which is uv minus the integral of v du. So we have uv minus the integral of v du. So if u is equal to x, du dx will be equal to 1. Now dv is sine x dx. Therefore, if you integrate this one, integrate sine x dx, so this will become, v will become negative cos x. So that is the value, that is v, negative cos x. Okay, so what we can do next is I'm just going to replace u and v and all this accordingly. So u is x, v is negative cos x, minus the integral of v du. So v is negative cos x, and du is this one, so du is dx. Du is equal to dx. So this becomes negative x cos x plus cos x dx, and this becomes negative x cos x. So if you find the entire derivative of this, that will be just equal to sine x plus c, and you can finalize the answer as such: negative x cos x plus sine x plus c. Okay, so that's the answer to the first question. Okay, next let's look at the next question, which is question B. Okay, so for question B, we have integral of ln x dx, and I can let u to be equal to ln x. Okay, so now you can say that let u equal to ln x. So this is u, and this one is dv. And dv is equal to dx. So if I differentiate du dx, differentiate ln x, I will get 1 over x. So this is 1 over x. And this one, if I find the integral of this, I will get v is equal to 2x. Okay, so my job is now to replace this with uv minus v du. Okay, I'm going to replace that with integral of ln x dx can be found by substituting uv v du. So u is ln x and v is equal to x minus v is x, du is just dx, du is just dx over x. So dx over x, so du comes from here, so du is dx over x. So clearly you can have ln x and x minus this one can be cancelled out, so you will get the answer here is x plus c. So that can be further simplified as x times ln x minus x plus c. Okay, so that's the answer to the second question. Alright, thank you very much for watching, and I'll see you in the next video with more examples related to integration by parts. Thank you.